This video presentation is associated with Module 12, primarily Chapter 5 in the Cooper text, and its overall focus is on the idea of ensuring trustworthy data, both in applied behavior analysis research and, more important to most of you, in applied behavior analysis in practice. Behavioral data, almost always directly observed data on behavior, is a critical basis for making decisions in research and practice in applied behavior analysis. If measures aren't chosen carefully, we don't design our measurement procedures carefully, and if we don't collect our data accurately, then very serious problems arise. And many of these problems are ethical in nature. We have responsibility to those for whom we work, and we have responsibility when we take on a project in the applied setting to work to produce significant, socially meaningful changes in the lives of those who employ us. This video is going to take a look at the indicators of trustworthy performance and ways to improve measurement and in ways to assess the accuracy and reliability of the data that we're using to make these important decisions as we analyze and change behavior. Things are covered nicely in your book, but there's basically three categories of indicators of the trustworthiness of data. The first indicator has to do with the validity. It goes back to the 7 characteristics of applied behavior analysis, that we need to be concerned about socially important behaviors. We need to be concerned about measuring them in ways that are accurate and to assure that the numbers that we produce when we measure behavior reflect actual changes in behavior of our clients and not the changes in behavior of observers. We have to be concerned about picking the correct dimension of behavior. We talked about those in the last, in Chapter 4, whether it's duration or whether it's repeatability or some other dimension of behavior. We have to make sure that when we make observations that they're representative of what's really going on in the natural and problem world. We certainly want to be interested in accuracy. Accuracy reflects the correlation between observational measurement and the real status of behaviors. Accuracy is not the same as reliability, as we'll find out. And we want to make sure that we're reliable, that we can consistently measure things the same way across occasions of measurement. These indicators are things that behavior analysts directly measure or consider when they're considering behavior plans, and they're not just the domain of researchers. Accuracy involves a direct correlation or the direct sameness really between the observed value from our observational measurements and a true value. True value is in some cases a difficult to assess idea, but certainly if we're looking at tantrums that a 3-year-old preschooler throws at preschool, we could agree that the actual number of tantrums as we define them that occur during a day would be a true value. How can we measure this? If teachers kept count of that, would they be different across teachers? Would it be different between a participant observer and someone who wasn't participating? If we didn't define them correctly, might we miss incidents? All these can make the correlation between observed value and the true value very different. And sometimes we're never going to actually be able to understand what the true value is. So it's conceptual in some kind of nature. It's easier to figure out the true value of things like permanent products. If we have a spelling test, for example, we could have 3 people go through it word by word and agree about whether a word is correctly spelled or not until we have a measure that we all agree is true. And then we could compare that value to another person who scored the test to see if they were accurate. And then we have the idea of measurement bias, that sometimes the way in which we measure behavior, we're going to talk about time sampling for example, might produce consistent biases in our observed values. So we are very concerned about accuracy even if we can't always directly measure it. There are many threats to the validity of measurement. One threat is the idea of measuring something indirectly versus directly, but not choosing the direct thing of interest. This is talked about in your book, and I think it's a very critical idea. We could pick the wrong dimension. We could be a case where we should be measuring the duration of something, and we choose to measure its latency or its frequency. And then there are measurement artifacts. If we don't measure things continuously, which is almost always the case for behaviors in natural settings, then there may be problems with when we choose to measure it, discontinuous measurement. Time sampling is a discontinuous measurement, for example, which we'll talk about here in a few minutes. We could not schedule our measurement in good ways. Maybe we only measure on Monday morning when the problem is always higher and we don't look at the problem across the rest of the week. And sometimes we might choose a measure that's not sensitive to change. Also a problem with sometimes happening things. So we always have to be concerned of and aware of the threats to making valid, accurate decisions about behaviors in which we have an important interest. The accuracy of measurement is threatened by poorly designed systems of observation, particularly threatened by not training observers correctly. So if we don't define behaviors well, and we decide to count them, and yet the way we've defined them does not accurately reflect the behaviors of concern in the natural environment, and then we don't train people to observe accurately, we're really collecting numbers that might have any bearing on what really happened, and we'll make poor decisions, and we'll make decisions that have a negative impact on our clients. We have to be concerned with the fact that even if we train observers well at first with good definitions and a good system, that accuracy can drift across time. Someone can, for various reasons, begin to collect inaccurate data. And we're going to look at inter-observer agreement and periodic calibration as ways to directly counter these kinds of threats. And also we could have unexpected influences on an observer. I work in a college environment. If I very heavily emphasize to my student observers my expectations, then maybe their observations will begin to reflect my expectations instead of reality. Observers in settings can create situations of reactivity where people act differently in their presence than they do in their absence. And finally, we can have complex observational systems where we try to measure many behaviors at one time. And if there's a high frequency across those, that can produce inaccuracy. So all these things can threaten accuracy. And the numbers we get, which seem so sure when they're written down, may have nothing to do with the actual numbers that occurred in the real setting, if we're not careful. We can only directly assess the accuracy of our measures if we can directly decide that something is true. Permanent products, we can typically do this. With observations, about the best we can do is to take, for example, videotapes of behavior and then have a series of observers go over it over and over again until they agree that they produced a true value. And then we could use that to calibrate actual observers. They could come and observe the videotape, and we could compare their observed value with our true value. This obviously is expensive and difficult to do in most applied settings. On the other hand, if you're working in a community setting where you collect standardized data across clients, this is relatively simpler to do, to have a series of calibration tapes and to directly assess the accuracy of our observers across time. So if we're observing behavior in real time, about the best we can do is to calibrate videotapes, digital measurement of recording of behavior, and use that as a true measure against which we compare observers. This assessment of accuracy is and can be different with behaviors in real time. Probably the most common way to examine the trustworthiness of our data in order to increase confidence that our numbers are meaningful is a thing called inter-observer agreement, which you can read about in your textbook. Inter-observer agreement is not a direct measure of accuracy or reliability. But if done correctly, it allows us to make an inference that our numbers are usable. It is important to look at the reliability of data by measuring inter-observer agreement. Again, inter-observer agreement is not at all the same thing as accuracy. Two observers could simultaneously observe a child in a school, for example, using a recording system, and they could both be wrong. But nonetheless, inter-observer agreement for practitioners and researchers is a necessity in order to accurately interpret data across time. It has to be done carefully, and we'll talk about it. And it's a metric of agreement between two observers observing the same way simultaneously. Unfortunately, research even shows that two people that observe together can drift off together into the world of inaccuracy. It's called consensual drift. It sounds romantic, but it's not. So inter-observer agreement can appear to be high, and yet both observers could be increasingly inaccurate. So there are things that need to be done once we even establish inter-observer agreement. Well, certainly in research, there's no excuse not to have inter-observer agreement, and without it, interpreting the results of research is dangerous. But in practice, we can certainly collect, even if it's a less frequent kind of thing, inter-observer agreement with important cases. Inter-observer agreement is collected differently for different types of measurements. And so we're going to look at some of them right now. We're going to look at the inter-observer agreement. That's what IOA means, for event recording, for time sampling, for measuring, for example, a task analyzed thing like making a sandwich, for example. We talked about chaining earlier, but you could measure a chained behavior. We'll take a look at these, and your book does a very nice example of this, and it's important that you understand these things. Please refer to your objectives for this module so you'll know what you have to be able to do. So the first one, and a simple one, is when we're simply counting things. A measure of inter-observer agreement, for example, would be to have two people observe simultaneously using the same system. It measures, say, tantrum behavior, and it counts them. And we would simply take the smaller value gotten by one observer and divide it by the larger value of the other. That could be converted to a percentage, and we could talk about a percentage of agreement. If we measured and counted things in time intervals, so every 5 minutes we tallied for 5 minutes in one block, tallied for 5 minutes in another, allows us to compute event agreement within an interval and then getting an average across an observational period, mean count per interval. That is done as long as we can group our counts across time intervals. It's a more precise way of looking at inter-observer agreement for events. But the typical way is for both people to count it and then to divide the smaller by the larger. What if we're measuring duration? Well, if we're both measuring duration with a stopwatch or some other kind of method, we would do it. So we're observing someone engaged in schoolwork, and we turn our stopwatch off when they start being engaged in schoolwork, turn it off. Next time they start being engaged, we turn it on, and we get a total amount. So observer 1 says that the person was engaged for 40 minutes out of the hour. Observer 2 says 50 minutes. The same thing. We could take the smaller measure, divide it by the larger measure, and this allows us to get the simplest form of durational agreement. We could also take each behavioral occurrence, measure its duration, and then compute that agreement for each occurrence and take an average. That's very clearly described in your textbook. That's a more stringent method and probably somewhat more accurate because it requires us to measure the duration on an occurrence by occurrence and then get a summative measure across those. We can do the same thing for latency or inter-response time. And to measure latency or inter-response time with the same method as the mean duration per occurrence, that's discussed in your textbook. We don't see a lot of observations of latency or inter-response time, but it does occur. For example, there's a method called differential reinforcement of other behavior, which requires us to set an interval, and that interval is taken from average inter-response times during a baseline period, so it can be important. These are discussed in your textbook. Time sampling is one of the most common ways to record behavior in both research and practice. And in your textbook, you've hopefully already read this, and it's talked about 3 kinds of time sampling: partial interval, whole interval, momentary time sampling. We talked about that in the previous video. It's very commonly used in functional analysis. So there are ways to compute inter-observer agreement. Unfortunately, there are multiple ways to compute inter-observer agreement, and they don't yield the same conclusions. And there has been some discussion about which one are most appropriate. Your book talks about looking at the actual observation and making a decision about which of the measures of inter-observer agreement to use. You could compute all 3 types of inter-observer agreement that we're going to talk about and report them, but you still have to interpret them. Your book also talks about criteria for what's an acceptable IOA in time sampling. Many say 80%, others say 90%, but nonetheless, it's going to depend to some degree on which of these measures you decide to use. You're all responsible for being able to compute IOA for time sampling, for example. The first one I'll talk about is occurrence agreement. And we're going to look at an actual sample here in a minute, but basically, as you know, in time sampling you divide an observational period up into intervals, and each interval is scored either as the behavior being present or not. And it's the rules for making that decision about presence that defines the different kinds of time sampling. In whole interval, for example, the behavior has to be present for the entire interval to be scored as present. In partial interval, it's got to be present just any part of the interval to be scored as present. Momentary time sampling has to be present at the exact moment of sampling. At any rate, an agreement is that both observers score it as present in an interval. A disagreement would be that one scores it as present, one does not, one scores it as absent. And we can create a percentage agreement by dividing agreements, however we define them, divided by agreements plus disagreements and converting that into a percentage. And I'm going to look at a couple examples here in a minute. We'll go over each of these three types: the occurrence agreement, the non-occurrence agreement, and the interval by interval agreement. So here's our first example. Assume this could be any kind of interval system. So let's assume it's a 10-second interval system. And in this case, you can look and see that we have 5 intervals representing, in this case, 50 seconds of observation. Observer 1, observer 2. Whenever we see an X in a cell, that means that that observer decided that the behavior by the definition was present. So let's assume this is a partial interval. So if the observer saw the behavior at any point in the interval, they would score it as present. And we can look and see that observer 1 scored 3 out of 5 intervals that it was present. Observer 2 scored 2 out of 5 intervals. And so let's look at what an agreement would be. For occurrence agreement, we're only concerned about an interval in which one or the other of the observers scored the present. So interval 1 we have a concern with. That's an agreement. Both observers scored it present. Interval 2, observer 1 said present, observer 2 said not present. It's a disagreement. We do not and we are not concerned when we're computing occurrence agreement with these if both score not present. So 3 and 4 don't play a role here. And 5 both agreed. So we have, in this example, 2 agreements, intervals 1 and 5, 1 disagreement, interval 2, and we can compute inter-observer agreement as follows. Agreements, 2, divided by agreements plus disagreements, which is a total of 3. 2 divided by 3 equals 0.67, rounded of course, and 67%. So the inter-observer agreement would be 0.67 in this case. If we ask what the rate of behavior was, observer 1 would say it occurred in 60% of the intervals. Observer 2 would say 40%. And whichever one we designated as a prime observer is the data we would use. That's occurrence agreement. This will illustrate the computation of non-occurrence inter-observer agreement. In this case, an agreement is that both observers do not score the presence of the behavior. A disagreement is if one scores and one doesn't, and if both score the presence, then it's ignored. So you can look here at this particular example and see that in cells 3 and 4 we have agreements, neither one of them scored. In cells 1 and 2 we have a disagreement. So inter-observer agreement would equal 2 agreements divided by 2 agreements plus 2 disagreements equals 2 divided by 4, or 50% agreement. And this would be true for a partial interval, whole interval, momentary time sampling scheme. Again, that doesn't make any difference. The only difference between the three really is the rules for deciding to score the presence of the behavior during the sample interval. And the final example will be the interval by interval. In this case, we score every interval as an agreement or disagreement. Agreements are either that both score presence or both score non-presence. So we can look and see that in the example here, cells 3, 4, and 5, intervals 3, 4, and 5 are agreements. 2 for non-occurrence, 1 for occurrence. And cells 1 and 2 are disagreements because the one scored presence and one did not. And you can follow the mathematics, but basically there's 3 agreements divided by 3 agreements plus 2 disagreements equals 60% agreement. And once again, the only difference between the time sampling schemes are in fact the rules for scoring presence. Inter-observer agreement remains important for almost any other kind of behavior measurement, not just the time sampling schemes or event counting. So permanent products, for example, can be examined for agreement of scoring. Let's take a spelling test, for example. Each word in the spelling test could be correct or incorrect. 2 different scorers could score a spelling test, and each time they agreed that a word was correct is an agreement, and if agreed it was incorrect, an agreement. Only when they disagreed would there be a disagreement, and there's the formula. It's the same. You could even take a behavior chain or a task analyzed chain, for example, like making a sandwich, divided into 10 different steps, and you could have 2 observers score whether each step is completed accurately or inaccurately and see if they agree the same way. So in research and in practice, inter-observer agreement provides one measure of trustworthiness of data. Again, it does not necessarily mean either observer was accurate. They could both be inaccurate. But it is a way to reassure us that the behavior has some, the observational measurement has some trustworthiness. The textbook covers other important information, including recommendations about the number of times and a series of observational measurements that one should collect inter-observer agreement, decisions to make about whether something is trustworthy or not, so what percentage of agreement is considered adequate. It also discusses that, typically speaking, more conservative measures are the ones that we should use, and which of the measures, whether for time sampling, whether occurrence, non-occurrence, or interval by interval, would be most conservative depends on a number of things, and those are discussed in your textbook. There's a section on how to report IOA, and certainly one could, if you were doing time sampling, could take all 3 ways of inter-observer agreement and report them all, but you have to draw some conclusions. Next semester we will read a number of research studies, for example, and we will pay attention to how these studies persuade us that the data are reflective of behaviors themselves and not the behavior of the observers. So whether it was inter-observer agreement or some video that observers calibrated themselves to, or whatever, we'll take a look at those over a number of different studies. And finally, it's worth talking about what one does as a practitioner to make sure, or to take some steps toward ensuring that your data are valid. These, of course, would be good advice for researchers, but they're more precise and technical considerations there. But at any rate, first, the target behaviors must be clearly defined. If you're going to count behaviors, you have to be able to discriminate beginnings and end. We don't use inferential terms in our observations and so forth. And the video that you could watch talks about these things. We have to be sure that the target behaviors that we intend to measure are the ones that need changing. And we have to ensure that the targets are meaningful themselves, and if the change of the targets would make a difference in the lives of the client. You should always write everything down. I work in educational settings and find too often that people count behaviors, for example, in classrooms, but they never wrote down the definitions. It's too easy to deviate there, and I think people that maybe don't research have a misunderstanding about the importance of these trustworthiness measures. It's very easy to make mistakes and produce meaningless numbers. So write everything down. Need to decide on what method of observation is appropriate, an event counting, duration, time sampling, and so forth. I find it's always a good idea to have a peer review what you've decided to do. There has to be some way to create a recording protocol. It's not a good idea just to scratch down things on a piece of paper. It's best to have some protocol. There's several examples of protocols on Blackboard. Even if you're doing it yourself, you should train and practice using the observations so you understand the problems and make unnecessary corrections. All these will not be necessarily the best, but they will be better than nothing. You have to consider when you're going to observe. If you can't observe all the time, what's your sampling plan? If you don't be careful about this, it's a good way to bias your data. And if you really are going to do inter-observer agreement, which can be difficult in practice, how often would you do that? Who might help you? Would you think it would be useful to create some videotapes and score them to create, for example, the true measure? Then you could. And I think then finally it's important, if you're collecting direct data, to review the definitions across time. I personally think the written definitions should be reviewed prior to each observation. It's easy to drift away from these. It's easy for 2 people to drift away together, and that's not romantic drifting.